Hello dear students, all of you welcome to Vidyan classes. Today we will start full course mathematics of 12th class. We have divided each unit into two levels, that is level 1 and level 2. In level 1, we will discuss all concepts and different types of problems at board level. In level 2, we will discuss some entrance questions. Let us start the first chapter of first unit, that is relations and functions. Level 1, lecture number 1. Heading: some important terms which are used in relations and functions. First, subset. It is a symbol of a subset. Let capital A and capital B are two sets. For every x belongs to capital A, that implies x belongs to B implies a subset of B. That means every element of capital A is the element of capital B, then a subset of B. Example: let capital A is the set of 1, 2, capital B is the set of 1, 2, 3, 5. A set contains 1, 2, B set contains 1, 2, 3, 5. Every element of capital A is the element of capital B, implies a subset of B. Example 2. Let capital A is the set of x belongs to real set so that x not equal to x. A is a set whose elements are real numbers where x not equal to x. It is an impossible statement. X is a real number, x not equal to x. So it is an impossible statement. Every impossible statement is denoted by phi. Implies A is equal to phi. A is a null set or void set or empty set. Let B is the set of x belongs to capital N. That means n is the set of natural numbers, so that s square minus 5x plus 6 is equal to 0. On simplification, that is s square minus 5x plus 6 is equal to 0. On middle fraction, it gives x is equal to 2 or x is equal to 3. Clear? On middle fraction, s square minus 5x plus 6 equal to 0 gives x equal to 2 or x equal to 3. So B is the set of 2, 3. Since phi is the subset of every set, since phi is the subset of every set, phi subset of B. Here phi is equal to A implies a subset of B. Clear? Note down. Note down. Next, modulus or cardinality or order of the set? What is modulus or cardinality or order of the set? The number of elements in a set is equal to modulus or order or cardinality. The number of elements in a set is called modulus or order or cardinality of the set. Example, let capital A be the set containing 1, 2, 5, 7. A contains 1, 2, 5, 7. The number of elements in A is 4. Implies modulus of A or order of A, which is same as number of elements in A is equal to 4. The number of elements in a set is called modulus or order or cardinality of the set. Example 2, let B be the set X belongs to R, that is the real set, such that capital B is the collection or set of all real numbers. S square plus x plus 1 is equal to 0. Find the cardinality or modulus or order of the set capital B. S square plus x plus 1 is equal to 0, which implies x is equal to minus b plus or minus b square minus 4ac divided by 2a, a not equal to 0. Here a is equal to 1, b is equal to 1 and c is equal to 1. So x is equal to minus b, that means minus 1 plus or minus b square, square root of b square minus 4ac, 1 minus 4 into 1 into 1 divided by 2 into 1, which is same as minus 1 plus or minus square root of minus 3 divided by 2, which is same as minus 1 plus or minus root 3 iota divided by 2. Not belongs to real set. X is equal to minus 1 plus or minus root 3 iota divided by 2. It is a complex number. X does not belongs to R. X is not real. So B has no real solution. B has no real roots. B is equal to 5. Modulus of B is equal to modulus of 5 is equal to 0. Clear? Note down. Okay. Next, power set. What is power set? the set of all subsets of a given set is called power set. Let capital A be any set. The power set of capital A is written as P of A and defined by P of A is the collection of, that means set of x, such that x subset or equal to A. The set of all subsets of a given set is called power set. Let capital A be any set. The power set of capital A, which is written as P of A and defined by P of A is the collection of x, so that x subset or equal to A. Example, let A capital A be the set containing 1, 2. Phi is the subset of every set, so phi subset of A, set of 1, set of 2, set of 1, 2, that is A, are the subsets of capital A. By the definition of power set, PA is the set of all subsets, that is phi, set of 1, set of 2, and A or set of 1, is the power set of capital A. Example 2, let capital A is the set of x, y, z. Implies as phi, that is null set or void set. Phi is equal to null set or void set. Phi set of x, set of y, set of z, set of xy, set of yz, set of xz, and set of xyz or capital A are subsets of capital A. Clear? 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 Okay. Power set of A is the set of all subsets phi, set of x, set of y, set of z, set of xy, set of yz, set of xz, and capital A. The power set of A is this. Set of all subsets of a given set is called power set. So power set of A is not in example 1 A mod is equal to 2, which is same as order of A or number of elements in A. A has 2 elements, implies as mod of power set of A is equal to number of elements in power set of A, that is equal to 4, which is equal to 2 square. Clear? P of A contains 4 elements. Modulus represents the number of elements in a set. Power set is a set. In example 2, A mod is equal to 3. Implies as mod of PA. A contains 3 elements. Modulus of A is equal to 3. Power set contains 8 elements. That is equal to 2 to the 3. When A has 2 elements, its power set has 2 to the 2, that is 4 elements, which is same as number of subsets of A. It is also number of subsets of A. In general, A mod is equal to n implies as mod of P of A is equal to 2 to the n, which is same as number of subsets of capital A. Clear? Once again, A contains 2 elements. Its power set has 4 elements. A mod is equal to 2. Power set has 4 elements. These 4 elements are the subsets of capital A. In example 2, A mod is equal to 3. That implies mod of P of A is equal to 8. That means number of subsets of capital A. In general, we can say A mod is equal to n. That implies mod of P of A is equal to 2 to the n. This expression implies if a set has n elements, 2 to the n is the number of subsets of A. That means modulus of power set of A represent the number of subsets of capital A. If a set has n elements, its power set has 2 to the n elements. These elements are the subsets of capital A. Clear? No doubt? Next, Cartesian product. What is the definition of a Cartesian product? Let capital A not equal to R, capital B not equal to R. The Cartesian product of A and B is written as A cross B and defined by A cross B is the collection of xy order pair such that x belongs to A and y belongs to B. A and B are two non-empty sets. The Cartesian product of capital A and capital B is written as A cross B and defined by A cross B is the collection of xy order pair so that x belongs to A and y belongs to B. From this definition, it is clear that Cartesian product is a set whose elements are order pairs or coordinate points. Note, Cartesian product is a set whose elements are order pairs or coordinate points. A cross B is the set of a xy order pair. Cartesian product is a set whose elements are order pairs or coordinate points. Clear? Okay. Example. Next. A is the set of 1, 2, 3. B is the set of 4, 5. Implies this. A cross B is the collection of xy order pair such that x belongs to A and y belongs to B, which is same as x belongs to A and y belongs to B. So the elements of A cross B are 1, 4, 1, 5, 2, 4 and 2, 5. 3, 4 and 3, 5. Clear? B cross A. B cross A. In A cross B, the x coordinate belongs to A, y coordinate belongs to B. With the collection of yx order pair such that x belongs to A and y belongs to B. So the elements of B cross A 1 4 that is 4 1, 1 5 that is 5 1, 2 4 is 4 2. Clear? 2 5 5 2. 4 3 and 5 3. Clear? Across B is 1 4 1 5, 2 4 2 5, 3 4 3 5. So B cross A 4 1, 5 1, 4 2, 5 2, 4 3 and 5 3. Since xy order pair is not equal to yx order pair, implies A cross B is not equal to B cross A. That means Cartesian product is not commutative. Clear? Clear? Note. A contains 1 2 3. Modulus of A is, or order of A or number of elements of A is equal to 3. Order of B or modulus of B or n of B is equal to 2. A contains 3 elements, B contains 2 elements. A cross B contains how many elements? A cross B or order of A cross B is equal to 6, which is equal to 3 into 2, which is equal to A mod into B mod. Clear? Implies A cross mod of A cross B is equal to A mod into B mod. In general, A mod is equal to M, B mod is equal to N, implies mod of A cross B is equal to mod of A into mod of B is equal to Mn. If A mod is equal to M, B mod is equal to N, mod of A cross B is equal to mod of A into mod of which is equal to Mn. Power set of A cross B has how many elements? If a power set, it is a set. If a set has mn element, its power set has 2 to the power mn elements. If a set has n element, its power set has 2 to the power n elements. Now, A cross B is a set, it has mn elements. Its power set contains 2 to the power mn, which is equal to 2 to the power a mod into b mod, which is same as number of subsets of A cross mod of P of A cross B represent number of subsets of A cross B. Clear? Mod of P of A is equal to 2 to the n. That is number of subsets of A. Here mod of P of A cross B which is equal to 2 to the power A mod into B mod, that implies or which is same as number of subsets of A cross B. Clear? Clear? Most important thing must be used in relation and function. Very, very important. Used in relation and function. Clear? No doubt? Next, relation. What is the definition of a relation? Let capital A not equal to phi, capital B not equal to phi. That means A and B are two non-empty sets. The relation capital R from A to B is written as R so that A R mark B, A tends to B, and defined by R subset or equal to A cross B. Definition of relation. A and B are two non-empty sets. The relation capital R from A to B is written as R so that A tends to B and defined by R subset or equal to A cross B. From this definition, it is clear that every relation is the subset of a Cartesian product. Note, every subset of A cross B is a relation from A to B. From the definition, it is clear that R subset or equal to A cross B, R is the relation from A to B. Every subset of a Cartesian product represents the relation. Note 1, note 2, since phi the subset of every set, we can say phi subset of A cross B. Clear? Phi the subset of every set, so phi subset of A cross B. Implies phi is a relation from A to B. Clear? Since phi subset of A cross B. Note 3, phi is equal to phi is called the empty relation phi is called the empty relation or void relation or smallest relation from A to B. Note 4, phi is equal to the empty relation or void relation or smallest relation from A to B. Since A cross B is the subset or equal to A cross B implies A cross B is a relation from A to B. 5. A cross B is equal the largest relation or universal relation from A to B. Clear? A cross B is equal to the largest relation or universal relation from A to B. Phi is equal to the empty relation or void relation or smallest relation from A to B. Clear? Since every subset of a Cartesian product, that is A cross B, is a relation from A to B. Since phi subset of A cross B implies phi is a relation from A to B. Phi is equal to the empty relation or void relation or smallest relation from A to B. Since A cross B subset or equal to A cross B implies A cross B is a relation from A to B. A cross B is equal to the largest relation or universal relation from A to B. Clear? Note down. Domain and range of relation. Let capital R be a relation from A to B, where A and B are two non-empty sets. That is R so that A tends to B or A armor B. Domain of R. R is a relation from A to B, that is R so that A to B, which implies R subset or equal to A cross. Domain of R, the collection of, collection means set, the set of all past members of the order pairs in R. The collection of all first members of the order pairs in R is called domain of R, or shortly DOM R. Mathematically it can be written as DOM R, that means domain of R is the collection of all first members of the order pairs in R is called domain of R. DOM of R is equal to collection of X, so that XY order pair belongs to R. R is the relation from A to B. Clear? Okay. Range of R. R means relation. The set of or collection of all second members of the order pair. Second members of the order pairs in R is called the set of all second members of the order pairs in R is equal to range of R. Mathematically it can be written as, which implies as range of R is the collection of second members XY order pair. It is the first member, it is the second member. XY order pair belongs to R. R is the relation. X is the first member of the order pair, Y is the second member. The set of all second members is called range of R. Clear? Clear? Next question. Let capital A is the set of 2, 3, 4, 5, 6 and capital B is a set containing 2, 4, 6, 8. The relation R from A to B is defined by R is equal to set of XY order pair belongs to A cross B, so that X divides Y. Find R, domain of R, range of R. Answer. R so that A to B, and it is defined by R is equal to set of XY order pair belongs to A cross B, so that X divides Y. X divides Y. X is the element of capital A and Y is the element of capital B. X belongs to capital A, Y belongs to capital B. Since XY order pair belongs to A cross B and X divides Y. X divides Y. X is the element of A. 2 divides 2. 2 divides 4. 2 divides 6. 2 divides 8. 2 divides 2, 4, 6, 8. 3 divides 6 only. 3 divides 6 only. 4 divides 4. 4 divides 8. Here 4 divides 4. X divides y. X is the element of A and y is the element of B. 5 does not divide 2, 4, 6, 8. 6 divides 6 only. 6 divides 6 only. So R is the collection of. So R is the collection of 2, 2, 2, 2 order pair, 2, 4 order pair, 2, 6 order pair, 2, 8 order pair, 3, 6 order pair, 4, 4 order pair, 4, 8 order pair, and 6, 6 order pair. R contains 8 elements. Since R is the collection of xy, where x divides y, x divides y, x divides y, x divides y. Domain of R, dom R, is the collection of x. That means first members. What is domain? Collection of all first members of the order pairs. So that xy order pair belongs to R, which is the set of all first members 2, 3, 4 and 6. Second, it is the first answer. So it is the second answer. Domain of R. Third bit. Range of R. Range R is the collection of second members of the order pairs. So that xy belongs to R, which is equal to second member 2, 4, 2, 4, 6, 8, 2, 4, 6, 8, 6, 4, 8, 6. Repetition of elements in a set are not allowed. So the domain is 2, 3, 4, 6 and the range is 2, 4, 6, 8. Domain is the collection of x values, that is 2, 3, 4, 6. Range is the collection of y values, that is second member of the order pairs, that is 2, 4, 6 and 8. Clear? Clear? Next, inverse relation. What is the inverse relation? If R is a relation from capital A to B, then the inverse of capital R is written as R to the power minus 1. The inverse of R is written is a relation from is a relation from B to A and defined by R inverse is the collection of Yx order pair such that XY order pair belongs to R. Or we can write Yx order pair is the element of R inverse. XY order pair is the element of XY order pair belongs to R implies and implies by XY belongs to R, that implies Yx belongs to R inverse. Or we can say Yx order pair belongs to R inverse, which implies XY order pair belongs to R. Or XY order pair belongs to R is the same as X, R, Y. Implies and implies by this and this are same meaning. Y R inverse X. X related to Y. Y R inverse X. Clear? If R is a relation from A to B, then the inverse of R is written as R to the power minus 1 is also a relation from B to A and defined by R inverse is the collection of Yx order pair so that XY order pair belongs to R. Yx order pair belongs to R inverse, XY order pair belongs to R. From this definition, we have XY order pair belongs to R and that implies and implies by Yx order pair belongs to R inverse. R and R inverse are the relations. R is the relation from A to B, R to the minus 1 is the relation from B to A. XY order pair belongs to R, which is same as X related to Y. Yx belongs to R inverse, Y related to X. Y R inverse X. Clear? This is same as this is same as this. Yx order pair belongs to R inverse, XY order pair belongs to R inverse. So that, question, so that R is equal to inverse of R inverse, where R is a relation from A to B. So that R is equal to inverse of R inverse. Proof. By definition, XY belongs to R, that implies Yx belongs to R inverse. XY order pair belongs to R, which implies Yx order pair belongs to R inverse. By definition. Again, XY order pair belongs to R, that implies Yx order pair belongs to R inverse, which implies by again interchanging, that is XY. When X and Y are interchanged, R will be R inverse and R inverse will be R. Clear? XY belongs to Yx belongs to R inverse, interchanging X and Y, which gives the inverse of inverse. Inverse of R inverse. XY belongs to R. Now XY belongs to inverse of R inverse. Now we have we have xy belongs to R and xy belongs to this. So this relation is subset to this relation. R subset R inverse of R inverse, and xy order pair belongs to inverse of R inverse. Xy order pair belongs to R. This is subset to this. This also subset to this. R inverse to inverse of R inverse subset of A subset of B, B subset of A, then A equal to B. Here R subset of inverse of R inverse and inverse of R inverse subset of R. Therefore, R is equal to inverse of R inverse. Clear? Clear? Note down. Next question. Let capital R be a relation from the set capital A containing 1, 2, 3, 4, 5 to the set capital B containing 1, 3, 5 defined by R is equal to set of xy so that x less than y, x belongs to A, y belongs to B. First bit write R and write down domain, codomain and range of R. Second bit show that domain of R is equal to range of R inverse, range of R is equal to domain of R inverse. R is the relation. Answer. The relation R from capital A to B is defined by R is equal to xy order pair so that x less than y, x belongs to A, y belongs to B. The relation is defined by xy order pair so that x less than y. So R is equal to x less than y. A contains 1, 2, 3, 4. 1 less than 3. 1 less than 5. So 1, 3 order pair is a point in R. 1, 5 is a order pair belongs to R. 2, 3, 2, 5. Since x less than y. 3 less than 5. 4 less than 5. Write R. R is the set of 1, 3 order pair, 1, 5 order pair, 2, 3 order pair, 2, 5 order pair, 3, 5 order pair and 4, 5 order pair. R inverse is the set of 1, 3 will be 3, 1, 1, 5, 5, 1, 3, 2, 5, 2, 5, 3, 5, 4. Since R inverse is the set of yx order pair so that xy order pair belongs to R. R inverse contains yx order pair where xy order pair belongs to R. Xy order pair belongs to R, yx order pair belongs to R inverse. Clear? 1 3 will be 3 1, 1 5 will be 5 1, 2 3 will be 3 2. Since R is this and R inverse is this. Clear? Write R and write down domain. It is the first bit. Domain of R. Domain means the collection of all first members of the order pairs in R. Is the collection of X so that XY belongs to R, which is equal to R is the relation this, the set of all first members 1 3 1 2 3 4 1 2 3 4. Clear? Clear? Okay. Range of R is the collection of second members of the order pairs in R. The set of second members of the order pairs in R. The second members, that is 3, 5, 3 and 5 only. Clear? Domain of R inverse. R inverse is the collection of 3 1, 5 1, 3 2 order pair, 5 2 order pair, 5 3 order pair, 5 4 order pair. The collection of first members, that is 3 and 5. The set of 3 5. A range of R inverse. The collection of second members of the order pairs in R inverse, that is 1 2 3 4. Clear? The collection of first members of the order pairs in R is called the domain of R. Collection of second members of the order pairs in R is called the range of R. Similarly, collection of first members of the order pairs in R inverse is the domain. The collection of second members of the order pairs in R inverse is called the range. Second bit A. We have to show domain of R is equal to range of R inverse. Domain of R is the domain of R is the collection of 1 2 3 4. 1 2 3 4, which is same as a range of R inverse, which is same as range of R inverse. Clear? So domain of R is equal to range of R inverse. Second bit, range of R is the range of R. What is range of R? The collection of 3 5. Collection means set, which is same as range of R inverse. Domain of R inverse. Domain of R inverse. Domain of R inverse is the set of 3 5. Range of R is equal to domain of R inverse. Domain of R is equal to range of R inverse. Hence proved. Note down. Clear? Okay. Next question. Let capital A and capital B be the set of real numbers. Define a relation from capital A to capital B by R is the set of xy order pair so that x square plus y square is equal to 1 and mod of x minus y is equal to 1. Find the domain and the range of R. Answer given A and B are same which is equal to R. Set of real numbers. Real set. Given A equal to B equal to R. That is real set. The relation from A to B is defined by R is the relation so that A to B is defined by R is the relation from A to B is the relation R so that A to B is defined by R is equal to set of xy order pair so that x square plus y square is equal to 1 and mod of x minus y is equal to 1. x square plus y square is equal to 1 and mod of x minus y is equal to 1. x square plus y square is equal to 1 is the equation of circle whose center is at origin and radius 1. x square plus y square is equal to 1 is the equation of a circle whose center is at origin and radius 1. It meets the coordinate axis at -1 0, +1 0, 0 1 and 0 minus 1. For x equal to 0, y is equal to plus minus 1. For y equal to 0, x is equal to plus minus 1. Clear? These points are satisfying x square plus y square is equal to 1 and mod of x minus y is equal to 1. As -1 0, that is -1 square plus 0 square is equal to 1 and mod of -1 minus 0 is equal to 1. For the coordinate point, that is 1 0, 1 square plus 0 square is equal to 1 and mod of 1 minus 0 is equal to 1. For the coordinate point 0, 1, 0 square plus 1 square is equal to 1 and mod of 0 minus 1 is equal to 1. For the coordinate point 0 minus 1, 0 square plus 1 square is equal to 1 and mod of 0 minus of minus 1 is equal to 1. Clear? Clear? It is the equation of a circle whose center is at origin. It is 0, 0. This point is 0, 1. This point is 0, minus 1. This point is minus 1, 0. And it is 1, 0. These 4 points satisfy s square plus y square is equal to 1 and mod of x minus 1, mod of x minus y is equal to 1. So the relation R. So R is equal to set of minus 1, 0, 1, 0, 0, 1 and 0 minus 1. R contains these coordinate points or order pairs. Clear? Clear? Find domain and range of R. Find domain and range of R. What is domain? The collection of all first members of the order pairs in R is called the domain. Domain of R is the collection of all first members minus 1, 0 and plus 1. Range of R. What is range? Collection of all second members of the order pairs in R. The second members are 0, 0, 1, minus. That is minus 1, 0 and 1. Domain of R is set up for minus 1, 0, 1. Range of R is also set up for minus 1, 0, 1. Here, domain of R is equal to range of R is equal to set of minus 1, 0, 1. Clear? Note down. Clear? Next question. Find the domain and range of the relation capital R given by R is equal to set of xy order pair such that y is equal to x plus 8 by x, where xy belongs to n. N means set of natural numbers and x less than equal to 8. Answer. The relation R is given by R is the set of xy order pair such that y is equal to x plus 8 by x, where x, y belongs to n, set of a natural number, and x less than equal to 8. Y is equal to x plus 8 by x. For x is equal to 1 implies y is equal to 1 plus 8, that is equal to 9. X and y are the natural numbers. For x is equal to 2 implies y is equal to 2 plus 4 is equal to 6. Both x and y are natural numbers. For x is equal to 3 y is equal to 3 plus 8 by 3 does not belongs to n. It is not a natural number. For x is equal to 4 implies this y is equal to 4 plus 2 is equal to 6. Both are natural numbers. For x is equal to 5, y is equal to 5 plus 8 by 5 does not belongs to n. For x is equal to 6, y is equal to 6 plus 4 by 3 not belongs to n. For x is equal to 7 implies this y is equal to 7 plus 8 by 7 not belongs to n. X is equal to 8 implies this y is equal to 8 plus 1 that is equal to 9. Both x and y are natural numbers. So there exist only 4 points 1, 9, 2, 6. It is not true since y does not belongs to n. It is true x and y both are natural numbers. It is not true. It is also not true. It is not true. And it is true. So there exist 4 points belongs to R. So R is equal to is the set of 1, 9, 2, 6, 4, 6 and last 8, 9. Both x and y are natural numbers. Find domain and range of the relation R. Domain of R is the collection of x values such that xy belongs to R. Collection of first members of the order pairs in the relation with the set of 1, 2, 4, 8. 1, 2, 4, 8. Range of R is the collection of second members of the order pairs in R so that xy belongs to R. 6 and 9. Clear? Note down. Clear? Next question. Find the total number of non-empty relations from the set containing xyz to the set containing AB. Total number of non-empty relations. Answer. Let capital A be the set of xyz. Capital B be the set containing small ab, which implies as modulus of A or order of A or number of elements in A is equal to 3. Modulus of B or order of B or number of elements in B is equal to 2. Total number of relations from A to B is equal to mod of P of A cross B, which is equal to 2 to the power A mod into B mod. Since R is the relation from A to B, implies R subset or equal to A cross B. Every subset of Cartesian product represent the relation. Every subset. Total number of subsets of A cross B is 2 to the power A mod into B mod. Total number of subsets is same as total number of subsets. Total number of relations from A to B is same as total number of subsets of A cross B. Total number of subsets is the modulus of P of A cross B. That is the power set of A cross B, which is same as 2 to the A mod into B mod, which is equal to 2 to the power 3 into 2, that is equal to 2 to the 6. Since phi is the empty or void relation from A to B implies total number of non-empty relations from A to B is equal to 2 to the power 6 minus 1, that is equal to 64 minus 1, that is equal to 63. Clear? Note down. Clear? Okay.